Hola, this is Hallie from Science Explorers. Today I've got a pH puzzle and I need your help to solve it. Here's what you need. You need the pH puzzle kit. You also need some water, measuring cups and measuring spoons, crayons, and some paper towels and something to cover your table with, just in case we get a little messy today. Pause the video to gather anything you need, then let's get going. We also need to remember some of our science safety. Today we're going to wear safety goggles for some of our experiments to protect our eyes. We also need to remember that in science we never taste anything. And of course, we also need to follow instructions. Acids and bases might sound like fancy science words that you'd only hear in a lab. But acids and bases are really all around us. Have you ever taken a sip of lemonade and tasted that tangy, sour taste? The reason it tastes tangy and sour is because it's acidic. Acidic means that something is an acid. But what does that mean scientifically? Substances that are an acid have a lot of hydrogen ions. Everything in the universe is made up of hundreds of thousands of tiny atoms. Some atoms have an electrical charge, and we call them an ion. If something has lots of hydrogen ions, that makes it acidic. A base is the opposite of an acid. Bases have lots of hydroxide ions. Baking soda is an example of a base. If you were to taste it, it would taste very bitter. And if you rub it between your fingers, it might feel slippery and soapy. In food, something that's basic tastes bitter. But there are lots of things besides food that are basic too. Scientists use the pH scale to measure how basic or acidic a substance is. The scale goes from 0 to 14. A substance that has a pH below 7 will be acidic. If it has a pH above 7, it will be basic. And if its pH is 7, that means it's not an acid or a base, it's a neutral. We can tell by tasting a food if it's acidic or basic, because they have different tastes. But what about things that aren't food? We can use a pH indicator. A pH indicator will change colors to tell us if a substance is an acid or a base. There are even some substances that are natural pH indicators. One of them is red cabbage. Red cabbage contains a pigment called anthocyanin. It changes colors in the presence of an acid or a base. If it turns red or pink when mixed with a substance, that means it's an acid. If you mix it with a base, it will turn blue or green. And if you mix it with a neutral, it will stay purple, the original color of the red cabbage. For this activity, we're going to need all of the 1 ounce bottles out of your kit. We've got 5 different liquids in 1 ounce bottles. Be sure that you get the 1 ounce bottle of vinegar and not the larger 4 ounce bottle. You're also going to need the red cabbage. You've got 2 of those in your kit. We only need 1 right now. We've also got some baking soda and an anti-acid tablet. We need 2 craft sticks and a pipette, 10 souffle cups, a 9 ounce cup, and some water. You're also going to need some crayons and a pencil to fill out your lab sheet. Be sure to put on your safety goggles for this activity. We want to make sure we stay safe. Pause the video to gather anything you need, and let's get started. The first thing we're going to do is pour water into 3 of our souffle cups. We want to fill them about halfway with water. These can set to the side for now. We also need to make our red cabbage indicator. Take all of the red cabbage in 1 capsule and pour it into the 9 ounce cup. Then fill the cup with water almost to the brim. I'm going to go to this middle line on the edge of my 9 ounce cup. And then stir with one of your craft sticks to get all of the red cabbage dissolved. Now we can test our different substances with our red cabbage indicator to see if they're an acid or a base. The first thing we're going to test is the baking soda. Pour all of the baking soda into one of the containers with water in it. Then mix it together using a craft stick. Once the baking soda is mixed with the water, use the pipette and add 2 to 3 pipettes full of red cabbage indicator into the water. Be careful not to put the pipette into the cup because we don't want it to get any of our substance we're testing onto the pipette. We want to make sure that none of our substances mix together. The color that your baking soda turned on your lab sheet. Does this mean that it's an acid or a base? Baking soda is a base. Next, we're going to test the vinegar. Get an empty souffle cup and fill it with the whole container of vinegar. Add 2 to 3 pipettes of red cabbage indicator to the vinegar. What color do you think it will turn? Make a hypothesis and let's find out. Our vinegar turned pink. It's an acid. Next, we're going to test the anti-acid tablet. Take one of your souffle cups with water and put the tablet inside. Then use the craft stick to stir the tablet until it dissolves. I think it's easier to press down on the tablet and rub it on the bottom of the cup so it dissolves a little faster. When the water looks cloudy and the tablet is dissolved, add 2 to 3 pipettes full of red cabbage indicator. Let's make a hypothesis. Do you think this is an acid or a base? It looks like my indicator turned dark blue. The anti-acid tablet is a base. Now we're going to test lemon juice. Pour all of the lemon juice into a new souffle cup. Let's make a hypothesis. Do you think lemon juice is an acid or a base? Let's find out. We're going to add 2 to 3 pipettes full of red cabbage indicator. Very pink. Lemon juice is an acid. Next, we're going to test some hand soap. Pour all of the hand soap into a new souffle cup. Let's make a hypothesis. Is the hand soap going to be an acid or a base? Let's find out. Add 2 to 3 pipettes full of red cabbage indicator. Be careful when you add this to the hand soap. It might splash. Let's mix this one with a craft stick because it's a thick liquid. Write down down what color it turned on your lab sheet. Mark if it's an acid or a base. Now we're going to test some rubbing alcohol. Pour all of the rubbing alcohol into a new soufflé cup. Do you think it's going to turn blue or pink? Make a hypothesis and let's find out. Let's find out by adding our indicator. What color did it turn? Mark that on your lab sheet. Now we're going to test some clear soda. Pour all of the soda into a new soufflé cup. Make your hypothesis and then let's test it. Write down the results on your lab sheet. And now for our last test, plain water. Take your last soufflé cup that we filled with water, make your hypothesis, and then let's test it. Water should be a pH 7. That's a neutral. So it should stay purple, like our red cabbage indicator. Sometimes water can have different minerals in it that make it an acid or a base. Mine looks like it might be a little bit blue, a little bit of a base, but we're going to put it in the center. Then let's line up our other substances if they're an acid or a base. If it's blue or green or even yellow, that means it's a base. If it's pink or red, that means it's an acid. We have all kinds of acids and bases. Now what we're going to do is see how acids and bases neutralize each other. Pick one acid and one base and mix them together. But first, make a hypothesis. What do you think will happen when you mix together an acid and a base? Here's a suggestion. If you don't know what to pick, try baking soda and vinegar. Here's a warning, this one might get messy. The baking soda and vinegar react and release carbon dioxide. But because they're an acid and a base, the indicator also changes color. When we mix together an acid and a base, they neutralize each other and make the substance turn neutral. Now it's purple instead of being pink like an acid. You can mix together any of your acids and bases and see if they'll change color. Take some time to experiment on your own. We even have acids and bases inside our body. One of the strongest acids in our body is hydrochloric acid. That's inside our stomach. Sometimes people have a problem where they make too much stomach acid, and that can hurt. They can use medicine, like milk of magnesia, to help neutralize the stomach acid. We're going to do an experiment to see how that works. Here's what you need. You need the other container of red cabbage, as well as the milk of magnesia and large bottle of vinegar. You're also going to need the 5-ounce cup, 2-ounce soufflé cup, a craft stick, and some water from home, as well as measuring cups and measuring spoons. Pause the video if you need to get anything. Don't forget your safety goggles, and then we'll get started. The first thing we're going to do is put a 1/4 cup and 1 extra tablespoon of water into our 5-ounce cup. So I'm going to use my 1/4 cup. And then 1 extra tablespoon of water. If you don't have a 1/4 cup handy, you can use your 2-ounce soufflé cup. That is also a 1/4 cup. Now we're going to add all of the milk of magnesia into this 5-ounce cup. Milk of magnesia has magnesium hydroxide in it. That's what makes it a base. The hydroxide ions interact with the hydrogen ions in the stomach acid and neutralize each other. Now we're going to add all of our red cabbage indicator into our milk of magnesia. What color do you think it will turn? Make a hypothesis and let's find out. Stir it up with a craft stick. At first, it's purple. Do you see what color it is on the bottom? Stir until all of the liquid is this blue-green color. This blue-green tells us that this substance is a base. Milk of magnesia is a strong base because of all the hydroxide ions. Now we're going to pour in a tablespoon of vinegar. What do you think will happen when we add a tablespoon of vinegar to the milk of magnesia? Make a hypothesis and let's find out. We saw in our experiment earlier that vinegar is an acid. And we know when we mix together an acid and a base, they can neutralize each other and turn purple. Do you think that's what's going to happen? Let's see. Stir together and see the colors change. I see some pink. And it's all turned pink. And now purple. And now blue. And now it's back to this blue-green color. The milk of magnesia neutralizes the acid and makes the whole substance into a base. Let's try adding some more vinegar and see if we can make it neutral. Pause the video and try it on your own. How much vinegar does it take to make this substance neutral? It takes a lot of vinegar to neutralize out the milk of magnesia. You can use the rest of your red cabbage indicator from our experiment earlier to test different liquids around your house. Only test liquids that a grown-up says it's okay to test. How about orange juice? Maybe some milk? Toothpaste? See what you can find out. Are these things an acid or a base? Have fun experimenting!